So follow, like and subscribe to this video channel. Today's coding challenge, or not so much of a coding challenge, is about feature encoding. At least this is what the title says. It says feature encoding over here, and what it actually means is that we take a set of data which is called the original data up at the top over here. So we've got our original data, and then we're going to do some coding, and that's going to become our encoded data over here. Now, the coding problem here, we're going to literally try to replicate this. The coding problem over here should be relatively simple, which is that we see that we've got a banana over here, and the banana gets encoded into a 0, and then we've got another banana over here which also gets the value of 0, and other fruit that will get other fruit values, but then we see a third banana over here, and basically according to our encoding pattern we should get another 0 here. Now this is weak encoding in a way, because if you discovered what any one of these were, then you would know the other two, so you could kind of like break the code that type of way. And the same thing happens with this orange over here, which is that the orange gets assigned the value of 2. I shouldn't have used that, so let me just hit the undo over there. I'll just use this little color over here. I'll use a green for it. The orange over here gets a value of 2, and likewise if we see any other oranges, we see one over here, it also gets the value of 2, and so forth. So we're going to now go along and try to do this encoding in Python. It's relatively straightforward. So although there are more complicated ways of doing this, and by all means add your comments into the video. So let's create our original data, ORIGINAL, our original underscore data, and we are going to put that into some kind of list like this, which is going to be a banana, and then we will have another banana, and then we will have an apple, an orange, a lemon, and then another banana, and finally we're going to have an orange in the list. If I spell it right, orange. Now the first thing, I'm going to zoom in on this as well, but we want to do some form of encoding over here. But the first thing is I need to try to respect our 7-character boundary line. I'll just undo that. Our 80-character boundary line to be consistent with PEP in Python, which is over here, and it cuts out our orange. So let's just make our list wrap around a little bit so that fits in. So let's just go back over here, and we will put all of our items like this. When our lists get a bit longer, it's more convenient to do something like this anyway, because it's more visible. So we have our original data that is formed by this list. And the next thing we want to do is to get our encoded data in some way. So like we need something that does encryption. And what I'm going to do is just use a standard Python dictionary over here. So D equals the dict. I don't have to do it like this. Remember, we can declare a dictionary like this. But it's quite nice to do it like this, which use the dict function over here, and we can see that the dict function, a new empty dictionary, so it's going to create a new dictionary, and here we'll have the same key value pairs, but basically what it does is it effectively does it like this, so we can put the actual dictionary key, the key equals the value. So let's just do that, dictionary, and our keys will be, so the first key is a banana, and that is going to be equal to 0. And the reason why it's equal to 0 is that we see these bananas are equal to 0 over here. Our next one's going to be an apple, so and that is equal to 1. And our next one here, I'm comma separating them, is an orange. So just press escape over this. We don't have this orange, and that is equal to 2. And what's next? We've got a lemon. So let's do that. Is equal to 3. And do we have anything else? I think that's it. We got to a lemon, because then we see that other characters are repeated afterwards. And this is like, effectively what this is actually a hash table or a dictionary, but we're going to call it our like encryptor. So we're going to use this hash table or this dictionary to encrypt, and in some way we need to get back our encoded data. And actually in a previous video, so I might actually link this to it, we could even use the map function. So that's one method that we can do. I might actually try to do that because it's quite cute. But the other thing that we can do anyway is we can say that encoded data, or we can either write a for loop. There's a couple of options of things that we can do. So one method is, we can choose any of these. We can do a for loop. We could do a list comprehension, which is a cleaner version of a for loop. But for the purpose of the video, if I'm going to go down that way, I would probably use a for loop, or we could actually use the map function. So which basically does an iteration through all of the items of the original data. Either one of these three methods are still going to iterate through the original data, but I'm going to go for the simplest one, which is a for loop in Python, so for I in range. But what we are actually going to use is our range is going to be the original data. So and then we could put something like for data in original data. And then what are we going to do? We're going to need some encoded data, which would also end up being a list. So we'll have our encoded underscore data, and that's going to be a list, and we're going to start populating this list. So we're going to do something like encoded data dot append, because we're going to keep adding items to this list. And what we're actually going to add is the data that comes in, so each item, but we're going to take the dictionary part of that, so D of, and then our data like this. So the first item in the list is a banana, so we're going to do D of banana, and that should be the value of 0. Then it's going to move on to the next one, the next one, and the next one. So we're going to try to replicate this exact picture. We're going to go through. If it sees a banana, hopefully we get a 0. Sees another banana, we get a 0. If it sees an apple, we're going to go and pull out the value of 1. So we can actually see this, that it should have actually worked, and we can just do this by typing encoding data here. We could do print encoded data, but there's no need because we're using a Jupyter notebook. So when we run it, we should get, no, we get a type error over there. So I just list objects cannot be interpreted as an integer. So whoops, I made the most basic of all mistakes. The iterable, it doesn't need to be stuck into a range over here. That was my mistake. That should actually just be for data in original data, not in the range of original data. So anyone watched me code for the last minute when I created that for loop, I should have actually done the original data straight away, not the range of original data. And actually it was ugly doing that. Anyway, the whole purpose of these for loops in Python is that we iterate through an iterable, and the original data, which is a list, was the iterable. So let's hopefully discover that this works. And indeed, we get the encoded data down here. Now we can make it look a little bit nicer, which is to do something like print and then will have our encoded data like this, but we just want to say what we've got. So something like this, which is, we could say, in fact, I'll steal some of the text here, that encoded data is this. Now, this thing here is for encrypting, and we could ask ourselves the question, although it's kind of like outside of the scope of this particular thing, but, or maybe I'll leave it for you guys to post this back as an answer, and I might do a second video of posting it back. But we've done some form of encoding. We've taken our original data here, and we've now transformed it into our encoded data here. We've transformed it into this set of numbers, and I think that we know what the question is going to be, which is, we know how to encode the data, so how do we decode the data to sort of like get it back to its original data format? So how do we do that will be the question. So we've done an encryption, and now we might want to do a decryption. So post your comments in the but first of all, hit the like button, hit the subscribe button, hit the follow button, forward it on to other people, but also a follow-up question, which is post in the comments or your thoughts of or even a piece of code of how you might do the decryption to get the other way. And that's it. Thanks for watching. This is encoding in Python.